All right, we have page 102, and we have all the odd number problems we're going to do here. This one here, it asks, graph the function and tell whether or not it has a point of discontinuity at x equals 0. So when we graph the function, what is that going to look like? Okay, if you get on your graphing calculator, you're going to see something like, now correct me if I'm wrong, you're going to see something like this, aren't you?
Yes. Wait, we don't know. We are.
And then something like this. Is that right? And so there you graphed it, and it asks the question, tell whether or not it has a point of discontinuity at x equals 0. Is that a yes?
Yes.
Yes. So yes. And then it say whether it is or not it's removable or non-removable.
What do you mean by that? That's what I
What
was.
does that mean?
Okay, removable means that we can cancel using algebra, right?
Yeah.
We can get rid of that x in the denominator by algebra, by canceling it out and eliminating it. Can we remove it?
No.
No.
What else tells us from the graph that it is non-removable?
I don't know. It's on the.
Because would it look like this if it was non-removable?
No.
No. It would look something like this, right? Where we would see just a line through or something like that, right?
Yeah.
So two things. So we say it is non-removable. So that's problem 21. Let's go on to problem 22.
Okay.
No, actually, problem 23, then we'll go back to 22. Okay, 23. We have
Okay.
this one here, same conditions, but f of x equals absolute value of x over x. This one here would be harder for me to evaluate without using a calculator. So let's try it with the calculator, see what it looks like to graph it. And if we go here, I'm going to press Control I,
It's just a straight line. Two straight lines.
graph, and then right here, was it
That you do that.
absolute value of, so I'm going to go here to absolute value of, you see where you get the absolute value?
Oh, yes.
You gotta go another that little thing.
You go to the little thing and you just go down one, so we're going to put in x there, and then we're going to divide it by x. Is that the extent of it? Okay, then we enter, and so we see this. Do we see, is there a point of discontinuity at x equals 0?
It's a one.
Is there a point, here's x equals 0, is there a point of discontinuity here? Yeah, right? Because it's not continuous, right?
Yeah, because it went up.
It
And
went
it's
up?
not straight across. It is just cross, but it's
Right.
like
What
it's
kind
a
of
gap in between there. It's a jump.
It's really a jump, right? Based on what we see here, because it all of a sudden goes from here to here. At least that's what it looks like. It looks like a jump. And we could see, is it removable or non-removable? Where are we going to see if this discontinuity is removable or non-removable? We can go to table view. Thank you.
I said that when I said it.
Very good. Control T.
Who gonna watch this? Who gonna watch
Teachers.
Nobody.
But
exactly.
it's not removable because it's a break, really. So even that it's there, it was my phone. I'm going to have to, if it was my mom, she's going to be in trouble. Okay. And she hered me say that too. If she watches this, she'll hear me talk about it.
Oh, it's
Okay.
Yes. Don't you think we're talking about me with your class?
Yeah,
Exactly.
exactly.
Okay.
So we say that it is, if there is a discontinuity, we say it is not removable, right? Because it broke. So we graph it, and I think it went like this, right?
Yeah.
And then like this, we graphed it, and is there a point of discontinuity? Yes. But we say that that discontinuity is going to be not removable. Okay, so let's go on to, we're going to go back to 22.
I still don't get the removable part.
Okay, well, just, you need to stay with this, and we're going to, I think that might partially be answered here on 22. Okay, here we have x squared plus x over x. X cubed plus x, so thank you. Thank you, Ms. for this. And so, if we graph it, and I'm really working from memory at this time, it's going to look something like this. Am I right? Is that right? Something that's not really well drawn, but you see it. Now, is there a discontinuity? And tell whether or not it has a discontinuity at x equals 0. Does it have a discontinuity at x equals 0?
No.
Does not. Okay? Remember we were talking about CSI?
Yes.
Okay, the evidence, the visual evidence tells you not, but is there other evidence that tells you there is? Did you get what kind of view where you get other evidence?
The graph.
The table view, right? This is the graph view, the table view. Does the table view tell you, we don't see discontinuity here, but does the table view give us discontinuity?
Yeah. Yes.
It does, right?
Yeah.
So, to graph it here accurately, what would we have to do?
Make a zero. I mean, a circle.
We'd have to make a little deal here, right?
It's a deal.
Open circle. I appreciate you holding me to specifics. Okay, so now we asked. So now we've graphed it. Is it removable or non-removable?
Non-removable.
Non-removable, removable.
Removable. It's non-removable.
That could be mine.
Okay, let's go ahead and see if we can remove it by algebra. Can we find the greatest common factor up here?
Yeah. No.
What's our greatest common factor of x cubed? Okay, so x, right? So x times quantity x squared plus 1 all over x. What can we do now? So, were we able to remove that discontinuity?
Yeah.
We were. So, we have, yes, there is a discontinuity. Okay, discontinuity. I'll put discontinuity, but yes, it is removable.
So it's a yes, yes.
Yes, yes.
Yes,
Yes.
Spelling is right. So, did that help answer your question? About what it... Did that help answer your question? Ms. Kemp? Ms. Kemp, did that help answer your question? About distinction between removable and non-removable?
But I don't know. I still don't get it. Because, like,
Okay.
that thing is like, oh, because you have to work that out like that.
Because we could do that, we did remove it using algebra. And so now, if you just graph this,
Okay,
you're not going to get this little point, open circle. And then, of course, in interval notation, you're going to have, not that it's asking for that, you have from negative infinity to 0, union, 0 to positive infinity. Okay, that's going to be interval notation. Yes, Mr.
So basically removing the denominator.
Part? Yeah,
Basically removing the denominator.
yeah, you got to remove the variable from the denominator. Like if you had a number here, if you had 3 times x, and you just remove the x, you would still remove that discontinuity.
Why
So you don't,
why is it not negative infinity to 1?
because it's at 0.
How is it negative infinity to 0?
Okay, they're talking about domain here.
They're talking about the domain, and each stop says 0.
Yeah.
0 is not
0 is here. Okay, this has to do with range.
It doesn't say
1. Okay, that's 0. That's a good question, though. Good question. That'll help us learn. Good questions help us learn. Okay, let's go on to the next one we have
Yes.
here.
Is that gonna be 24?
No,
Oh.
it's going to be 25.
That's it, Fred.
Okay, it says, for 25-28, state whether each label point identifies a local minimum, local maximum, or neither. So we're going to talk about, is this a -1, 4, a local maximum, or local minimum, or neither?
Yes, medium.
Neither.
I guess it's in the middle.
That's
It had to follow.
It makes a
It's
little.
no maximum.
That's a middle. Wait, because it's in the middle. I mean,
Okay, another question. Okay,
Yes.
wouldn't that be a medium
Yeah, but
because
it's
like
not the
the
middle.
lowest point that's like on there is 2, it's farther down, and then at 5 is above that. So wouldn't that be in the middle?
Yeah, so it's kind of in the middle, but what the key thing is local. Local maximum, minimum. So local doesn't mean the whole function, it just means relative to a small portion of it.
To them.
So if we just look at this, is this going to be a maximum?
No.
No. What?
If we just look at this and what I circled, is that going to be a maximum?
Oh, yeah.
By itself, that's gonna be a back.
Oh,
yeah,
whole
section. Yeah.
So we say this is a local maximum, so I'm going to put L max.
Okay, I get it.
Right?
Oh, because it's like at the top of the
Yeah, just for a limited part of it. Okay, now,
I still don't know.
now we're going to go ahead and look at this bottom portion. Is that a local
That's a
maximum?
minimum.
No, the other part is lower than that. Minimum.
Local
And that
minimum.
one at the top is a maximum.
Yeah.
It'll be a
Maximum.
local maximum.
That was a maximum.
Yeah.
And this actually might be an absolute maximum because,
It's 5, 5.
yeah, we don't even
It's
see,
5.
yeah, this is 5 and this is 4, so this might also be based on what we see, it's also an absolute maximum.
Yeah.
So I'm going to put A max for absolute maximum 2. And then it's asking, identify intervals on which the function is decreasing and increasing. Which intervals are this function decreasing?
It decreased in between.
Between
I need to-
Negative
-1 and 4.
Two.
And then
It's decreasing between 4 and 2.
Okay, -1 to 2.
oh, it's so cold.
And also,
And 5 to, and I don't know, I don't know. That's when I graph the,
let's say that it just keeps on going. How far is
to
it?
infinity.
Oh, infinity.
Mr. Doyle, can I go to the restroom?
How much lower?
Okay, now, that's decreasing, so, and then increasing.
It increases at negative infinity to -1, and then to 2 to 5. I know I do this removal. Okay, good look.
Okay, is that going to be right?
Is that?
Yeah, so decreases 2 places, increases 2 places, right? Okay, let's go on to 27.
That's how it is.
And the even numbered ones are going to be similar type of rigor, difficulty.
So you hate the last 100?
Okay, next. 27.
Okay, focus.
Is this a local minimum, local maximum, or neither?
Neither. Why? Because it's like it goes straight and it goes up.
Yeah, it really doesn't
So
make
you
a
don't go like
maximum.
yeah, you don't
So
go
you can't
down.
tell. Okay, so that one, that's 1 5. Would
That'd be a maximum.
Yeah.
Yeah,
And
and
so would that 3 3 would be a neither? Yes. And then that 5 would be a
low
maximum. The lowest, right?
Yes.
Oh, you got it, girl.
you guys are catching on fast. Okay, this would be
Okay, so it's okay.
Low minimum.
Oh, at this point.
So what about the dot?
okay. Let's talk about the dots because that's going to come into play maybe when we identify intervals for increasing and decreasing. So let's go ahead and put decreasing.
Okay, it decreases at 1 to 3, and
From 1.
You say it
from 1 to 3.
Okay, it decreases there, and also
I got a question. question. Okay, because you know that thing, it ain't going like down, like all the way. Got the little
So it's just kind of leveling off a little bit. It's kind of leveling off a little bit, right?
Do you count that in there? Is that so? That's
What
not
do you think?
necessarily
This is a good point of debate. Ms. Kemp has a good point of debate. Do we count that as far as, in other words, you're saying, is it going to be broken up from 1 to 3, and then from 3 to 5, or just straight through?
So why should you do that?
No, because it's like leveling off and then
Yeah,
it go
but it's
down
still
some
going
more.
down while it's leveling off.
This is good discussion y'all
You
are
can't
having.
level off and go down at the same time.
Look at that. It's going down.
Okay, how many agree with, okay, we have a debate between Ms. Kemp and Mr. Johnson. Who agrees with Mr. Johnson?
What he said?
He says that he says, okay, this is Mr. Johnson's version. He says decreasing, correct me if I'm wrong, Mr. Johnson, we have decreasing like that. Okay, and then,
It's negative.
and then we have
I mean, never mind.
1, 2, 3, union 3 to 5. So this is Ms. Kemp's version, right? So who's Mr. Johnson, Ms. Kemp?
Whoa.
Don't you start with
It's
negative?
going all the way down to 5.
Oh no, yeah, that's right. She's right.
Okay,
Not really.
thank you.
It goes all the way down to 5.
Okay, there we go.
Yeah, but it, like the other one, it said decreasing from -1 to 1, 2, 3.
So now he's gonna be there.
And then it's divided by 3.
They agree with me.
Local maximum.
Okay, how many are going to vote
Is this
with
domain? Is this like domain?
It's
Mr.
getting smaller, right? I'm confused.
Who votes with Mr. Johnson on
What it
this?
said.
What is it?
You're not listening.
This is Mr. Johnson here. This is Ms.
It's
Kemp.
just
What is
ignoring
it?
me, dude.
What you talking about?
I think
Decreasing over this
We talking
or
about
decreasing over this?
Right.
Yeah,
What I meant
like
was
on there
when
because
I
it's
went
like
down to 5.
1,5,
3,
and then it's
and
not,
then
and it's a
3 to
point at
5,
3 to 3,
and
and
then
it's
it's
like
gonna go
5, 1.
to
Yeah, just 'cause
1.
it's a
Is it
point doesn't
continue
mean
all the way
stop.
down, or
Then
is
it's
it
gonna
stop
go
and then go
from-
When it looks like it's leveling off,
It's gonna
still
continue
going down.
It's gonna continue all the way down.
Yeah, I'm
No.
over hers, but she still needs one more.
See, I don't think it exactly
Yeah,
levels off
That's what I'm
quite.
saying. It didn't exactly level off. It's still going
So I
down.
think it's still decreasing, but at a lower rate. So just based on what I see, I'm more tempted to be with this. That's my opinion. That's
I wouldn't have did that and I would have got it wrong because I was
I still don't know what y'all talking about.
now. I hope that if I wrote a test question, I would be a lot more clear about writing it, describing it, because it looks like it could level off, right, to not increasing. So, but I think based on what I see, that's what I would do. Any place else is decreasing besides here?
I would get it wrong. That
No,
part.
just one place. Okay, increasing.
But really, it's still. I know it.
It was just me from like 3 to 5.
Basically just mark.
Increasing.
3 to 5.
Basically just mark the part that's increasing.
No, it's decreasing 3 to 5. Where's it increasing?
The other 3 to 5. Now it's still decreasing some.
She thought that it's like,
Where's-
leveled off right here.
3 to 5 is decreasing.
But it's still.
So negative infinity to
Oh, -5. So we use the first number, we use the last.
so negative infinity to 1, right? So it increases from negative infinity to 1, and increase again from 5
He's
to.
looking at it like he's nasty.
So is that right?
Yes.
Okay, good. I like the discussion. There was a little passionate debate there. I like that.
Are you
It shows you're
recording it?
investing in your learning. Yeah,
Okay, I'm gonna do it just like that.
this is going to be good.
You're getting paid into the.
Those are the kinds of discussions you need to be having in class. That's good.
Okay, now I'm gonna need help with all these other stuff because I don't got no people at home.
Okay, here we have f of x equals that. It says identify intervals where it's increasing, decreasing, or constant. And so we have, I'm just going to write over here,
Well, I gotta put you.
What is that?
x plus 2 minus 1.
I'll put you out.
So you're still buying.
So we go to our calculator,
I got a like a V shape. Is that supposed to be right?
and in our calculator I'm going to press control, insert,
I know that much.
graph,
No.
and then put this in here. We go with, first of all, the fraction, right? No, not the fraction. It's just this, right? We have x plus 2
So it makes like a V kind of
plus 2. And then we come outside of that absolute value bar.
What is funny?
And then that's going to be minus 1. And we enter that. Okay, it says identify intervals. Where's the intervals where it's decreasing?
From negative infinity
Negative
to
infinity.
negative 2.
Decreasing negative infinity
To negative 2.
to comma negative 2.
Yeah.
Negative 2.
And then it said,
Then increasing.
and then it increased from negative 2 to negative 1.
Yeah.
It's negative 2. I mean, like, it could be a negative 2. Right?
Okay, that's why I don't know what else is asked for there besides that. Good. I'm just going to work it while he's talking because we still have time in class.
I had a question. How would you work this out by hand? Or into the way of working it out by hand? Yeah.
I'll show you.
Show me, I need to know. I'm only like to use calculator.
Now look at him. Now look at that kid.
Also, students and staff, it was not announced this morning, we will have a community meeting.
See what I'm doing?
Oh.
Negative 3 plus
Oh, we just
2.
plug it in?
That's going to be
Huh?
negative 1. Absolute value of negative 1 equals 1, right?
That's what we do when we just plug it in to do it by hand.
Yeah, then,
Okay, well I got that. I'm
Okay.
good.
so,
Can you pass it that way? Thanks, white boy.
To the gymnasium, and then we're going to second year, we will call for all Eagle women. Female students in the course of the gymnasium. We overcome the expectations academically and socially for this too.
We'll turn this into you.
Eagle women.
Great day again, everyone. Thank you for making me great. This is a great work here. So much is
What is she looking at?
and then we have plus x plus parentheses x, sorry, absolute value bar is x minus 1. This will be the last one we do. Oops.
It's like a little, you know, thingy with you.
Plus, oh, that's divided by, no wonder. Plus,
Have it to the trash. Chris,
Can I go drink some water?
yeah, x minus 1.
Oh my God, I got a whole bunch of questions for him.
And then we have minus 2.
Lisa, so where do I go?
Go straight to the gym.
Okay, I gotta go outside and do my clothes for my mama.
So what we have here, oops, I
What's it called when
missed that.
You're short in school.
Let me go to tab, fix that.
But they, the dog, not talking about,
I'm gonna stay right there.
you're not talking to the coach until the,
She don't know you what she got. We got like.
Okay, this is number, okay, ladies and gentlemen, settle down.
Settle down.
Okay, this is the one here, the last one we're going to do. It comes down, where's it increasing, decreasing, neither?
It increases at 1 into.
So
No, it
1,
increases from 1 to infinity.
1,
That's where
comma,
it
infinity.
increases from negative infinity to negative 1.
And negative infinity
To 1.
to negative 1.
1, negative 1.
from negative infinity till negative 1.
And then negative 1, comma, 1, right?
Yeah.
To infinity and beyond.
And so this tells you where it's decreasing, where it stays the same, increasing, right?
Right.
So I'm going to put decreasing,
Debt.
constant,
You don't get lead points.
and increasing.
Is that good?
That's pretty good to work through. Now I'm going to go ahead
Good.
and minimize. And so we can see it right there, our problem, it's worked out. So we will just stop there. Thank you, class.
You trying to